When we find zeros by completing the square, the first thing we want to do is collect the terms with the variables on one side and the constant term on the other side of the equation. So here in number 1, I have p squared plus 14p minus 38. So I need the p squared and 14p to be by themselves on the left side. So I need to move this negative 38 to the other side. So I'm going to add 38 to both sides of the equation. Now I'm going to have my p squared and positive p on one side, and now a positive 38 on the other. So now I'm going to make sure that my a term is 1. So since I just have a p squared, my a term is 1. And then I can take my b term of 14. I'm going to divide that by 2, which will give me 7. And I'm going to take the 7 and I'm going to square it to give me 49. So what I'm going to do is I'm going to add that 49 to both sides of my equation to create a perfect square trinomial. So I'm going to have p squared plus 14p plus 49 equal to 38 plus 49. Remember, we have to keep our equations balanced, so what we do to one side, we have to do to the other. Now the left side, I'm going to factor. So I can use either the British method or the box method. Now that I have finished factoring, I get p plus 7 and p plus 7, so that simplifies to give me p plus 7 quantity squared. And then I can take my 38 plus 49, and that's going to give me an 87. So now this looks like something that we saw when we were solving equations using square roots. So I'm going to take this square root on both sides. That'll leave me with just the p plus 7 since the square root eliminates the exponent of 2. And I'm going to simplify the square root of 87. So two numbers that multiply to give me 87 are 3 and 29. Both of those numbers are prime, so my answer is just going to stay as plus or minus the square root of 87. Don't forget that plus or minus sign. Now I just need to get p alone, so I'm going to subtract 7 from both sides. That 7 will just go up in front of our plus or minus sign. So p is going to be negative 7 plus or minus the square root of 87. I'm going to do the same thing in number 2. So I need to get my variables on one side. So as of right now, I have a 5k squared on the left and my negative 20k on the right. So I'm going to add my 20k over to the left side. That way I have the 5k squared and the positive 20k all together, and that will equal 60. So I need my a term to be 1. So for that to be 1, I need to divide by 5. And when I divide by 5, I have to divide all of the terms in the equation by the same number. So my 5 divided by 5 will give me a k squared. 20 divided by 5 will give me a positive 4k. And that will equal positive 12. Now that my a term is 1, I can take my b term of 4 and divide it by 2. That'll give me a 2, and I'm going to square it, and it will take me back to 4. So I'm going to take that 4, and it's going to get added to both sides of my equation. So k squared plus 4k plus 4 will equal 12 plus 4. Now I'm going to factor that left side, the k squared plus 4k plus 4, using either the British method or the box method. Now that I have factored, I get a k plus 2 and a k plus 2, which simplifies to give you k plus 2 quantity squared equal to 12 plus 4, which is 16. I'm going to take the square root on both sides. The square root will eliminate my exponent of 2, and it'll leave me with just a k plus 2. And the square root of 16 is 4. So I'm going to have a plus or minus 4 on the other side. Now to solve for k, I'm going to subtract 2. And when I subtract 2, I still need to put that negative 2 in front of the plus or minus sign. So my k is going to be -2 plus or minus 4. Since I have two whole numbers, I can actually figure out what the actual answers are going to be. So I'm going to break this up into -2 plus 4, which is going to give me a +2, and a -2 minus 4, which will give me a -6. So my two answers are going to be 2 and -6.